Hello everyone, welcome back to the channel The Engineering Essence. Today we are going to discuss an interview problem from Leetcode called threesome. So it's an medium Leetcode problem. You can see the label. So the problem statement is like we have given an integer array nums. Okay, so we need to return all possible triplets, whatever it can be available in the given array. Nums I, nums k, nums k kind of output we need. So the condition is that the I should not be equal to j, this I also should not be equal to k, similarly the j should not be equal to k. Means we have to find the triplets such that the sum of the all the three triplets should be equal to 0. Okay, so we need to find the all possible triplets. And one more condition that we have to notice that the solution set must not contain any duplicate triplets. I mean, whatever possible triplets we do have, it should not contain the duplicate triplets as well. So yeah, this is the problem statement. So if I give an example like what it is one from our solution is that. So let's take this example number one. So we have this nums array and we have this output. As we can see, we can have in this array we can have three possible triplets. Okay, which sum will be equal to 0. So the first triplet will be like -1, 0, and 1. Similarly, we have a 0, 1, and -1, and the third one is like this one, 2, -1, and -1. So these three triplets will yield 0 when we sum the elements. Okay, so these are the possible triplets, but we need to find the distinct triplet. Okay, so from you can see here from these two we can pick any one, and this one will be the second triplet. So we have a total two triplets in this array. Okay, so here we can also see that the order of the triplets element whatever it contains, it does not matter, and the order of the whole output it also does not matter. Okay, we can give any order of the output and we can have any output of the triplets. So let's talk about the solution approach. If we talk about the brute force approach, so we need to use a three for loop. In that for loop we have to like iterate the whole array, and in the final loop we need to check whether the sum of the element will be equal to 0 or not. If it will be 0, then only we need to collect the triplet into the resultant array. But it will produce the order of n cube time complexity, which will be not accepted by this question. As on the large array, it will take a long time and it will not accept the solution. So the optimized approach will be like we need to sort this array. Okay, first we need to sort this array. So I've just taken this sorted array in this code section. So this is the sorted array. After that, what we need to do, we have to apply loop on the whole array, and then after we need to fix element. Okay, so let's say if I fix this one, then we have the remained array like this one, -1 to 2. On the remained array, we need to apply two pointers. Okay, left and right pointer. So left will point here and right will point here. Okay, after that, when we take the pointers, we need to apply another loop on condition of like left pointer will be less than right pointer. Okay, we will iterate the whole pointer until unless the left is less than right. So after that, we need to sum all the three elements whatever we have taken, like the fixed element and the left element and the right element. Okay, inside the another loop. So after calculating the sum of these three elements, we need to we will have three conditions. Okay, so let's say we have sum like this one, is equal to the fixed element plus the left pointer and the right pointer. Okay, so okay, so on behalf of this one we have three conditions. So the first condition will be like if sum is equal to 0, and the second condition will be like if sum is equals to sum is less than 0, and the third condition will be like if sum is greater than 0. Okay, so in the second condition, if sum is less than 0, let's say we have the sum, we calculated the sum and it is less than 0. Okay, it need to be increased, it need to be moved. I mean, the left pointer should be moved to right, because if we move to right side, then what we get positive elements. Okay, so if we sum the positive element, then our sum will be approached to the 0. Okay, so that's why we have to move our left pointer one step ahead. like this one. Okay, similarly, if sum is greater than 0, so this means that our value is more positive, so we need to decrease our sum. So how we can do this? We have to move our right pointer to the right side, because on the right side we get negative element, so we will do r minus 1 is okay. So the these two condition is covered by like moving all pointers on the respected direction. And then after if we have the sum like 0, then in this case first we will check like we have an repeated element or not. Okay, so if there is a repeated element, then we have to ignore the duplicate triplets. As you can see in the question, we have to ignore the duplicate triplets. So for ignoring duplicate triplets, what we need to do, we need to move our pointer left or right, okay, until unless we get the duplicate element here. You can see that like minus 1 is duplicate. Then in this case we have to move our pointer from, let's say, left till pointing this element, then we have to move our pointer to this one, because these both these two elements are similar. So what we have to do, we have to move this element. So for moving this one, we have to apply a while loop, and also need to check whether our left pointer is less than right or not. And also need to check the nums l is equal to nums l plus 1. Okay, if this condition sets fine, we need to uh, move our element, okay, like this. Similarly, if we have other element from right side, so same condition need to put, and also check whether our nums r is less than equal to nums r minus 1. So these two conditions will remove the duplicates, okay, duplicate triplets. So okay, after this we need to collect these triplets inside of the resultant array. Okay, so yeah, this will be the solution approach that we will going to use to solve this question. So let's move to the implementation of the approach that we are going to use to solve this question. So yeah, we have this method threesome. So first what we will do, we will sort our array. We will sort our array. So arrays dot sort nums. Okay. After that, we will applying our first loop on the whole array. So I will equal to 0 and I less than numbers. So okay. After that, we will create our two pointers. Left will be equal to I plus 1. So we will take left pointer just one point forward element. Okay, and the right pointer will be equal to nums dot minus 1. Okay. Also, we to remove the duplicates, what we will do, we will also check whether our nums I will be equal to nums I minus 1. Okay. And we will also check if this will check only when it is equal to greater than, it is greater than 0. Okay, only then it will check nums I is equal to nums I minus 1 or not. If it will be like this, then we will just continue our loop, because we have to ignore the duplicates. So first we will start from here only, and then we will do in the second loop as well. So I will going to apply the second loop as while, which will run half of the remainder element. So it will be less than r, and after that we will create another variable which will be sum of the three uh, numbers, three elements, whatever it is we have taken here. So nums I plus nums l and plus nums r. Okay, so these are the three tuples we are going to sum. After that, we have three conditions. If sum will be equal to 0, then what we will have to do? Else if we have a sum is less than 0, okay, and else what we have, okay, the else part is when sum is greater than 0. Okay, so these three conditions we have. So if we have sum less than 0, then what we have to do, will have to do, we move our pointer one step ahead, one step forward. Okay, we will just do r minus 1. That's it, because we have to decrease our value so that we get the 0 in the sum. Okay, so decreasing the sorting will help us to find our left and right pointer to move it correctly. Okay, so what we have, and the okay, so these two conditions are completed. The third condition, this one, like sum is equal to 0. So we will do like we will okay. Also, one more thing that I want to add here. So we have a list of list. It will be equal to sum. Equal to this. We will take array list here. When we got sum is equal to 0, then what we will do? We will do rest dot add this one. Nums I psi nums L and nums. Okay. So we will add like this, and we will also increase our pointer to the left and decrease our right pointer to the right. Okay, so okay, apart from this, what we will do, we have to ignore duplicate triplets. Okay, so for this, what we will do, we will move our left pointer to the right. Okay, we will move our left pointer to the right until we get the same element. Okay. So what we will check, first left should be right, left should be less than right, and and nums L, if nums L is equals to nums L plus 1. Okay, then what we will do, we will just move our left pointer to the right. Okay, similarly for this one, L should be less than R, and nums R equal to nums R minus 1. Then also we will do we'll move our right pointer to the left side. Okay, so these two conditions we have to keep in mind for this condition and this one. These three conditions we have to keep in mind to remove the duplicate triplet. Okay, so it will help us to remove the triplets, and okay, we will move our two pointers like this one after adding these things, and also we have to take care of these things, like if we have a sum is less than 0, then we will move our left pointer to the right side, and similarly we have greater than, then we will move our right pointer to the left side. So yeah, this all we have to remove the return the resultant variable result element. Okay, so this is the solution, guys. Okay, so let's check our solution is working or not on the simple test cases. So yeah, you can see here our solution is working on the sample test cases it is given by the Leetcode. So yeah, guys, I have submitted the solution, and it solved the question in 31 millisecond and beating 81.72% implementation on the Leetcode. So yeah, this is our implementation that we have used to solve this question. So yeah, this is. So guys, that wraps up today's lecture on the Leetcode problem. If you found this explanation helpful, don't forget to like the video, subscribe to the channel and hit the bell icon so you will not miss the future tutorials. Thanks for watching, and I will see you in the next one. Thank you again.